Alright, howdy boys and girls, mathematicians. This is Mr. Trutna from Clovis High School. Today we're going to be talking about imaginary numbers, okay? So in this lesson, what we're going to do today is we're going to go over what's the definition of an imaginary number. We're going to talk about the I wheel, and then we're going to talk about how do you add and multiply with imaginary numbers. Okay, so the first thing though, before we get started, is that you all have to know that whenever we use the term imaginary numbers, that also is synonymous with the term complex numbers. So, imaginary numbers, complex numbers, they tend to show up at the same time. Okay, so like I've always said in the class, if for fun you read a math book and if you looked up a chapter about complex numbers, you would probably see imaginary numbers. Imaginary numbers are always going to be represented by the letter I, and you write the letter I for imaginary numbers in kind of a lowercase cursive sort of deal right here. Okay, so to get started right here, we got a joke for you. You won't understand the joke right away, but you might get it. So we've got the guy from The Big Bang. You must be the square root of -1, he says, because you can't be real. You'll get the joke hopefully by the end of the lesson here, and if you don't, well, I don't know what to tell you if you don't get the joke. Okay, so first of all, a little bit of history on the imaginary numbers, or not the imaginary numbers, okay? But a little bit of review before we actually get started. So you should be actively taking notes as you're watching this video here. You should be writing down information as I put it down in the information as well. Okay, your chances of remembering it obviously they're better than if you're not remembering, if you're not writing it down. Okay, so Kaysen, I know you're a mathematical savant. Ethan, I know you're a mathematical savant and you feel like you don't have to write much down and you could do it all in your head. Prince, you too, but you still want to write it down, okay? Evan, you probably want to wake up for this, okay, and you want to stay with it. Hunter, if Christian starts falling asleep, go ahead and give him a little bit of a nudge. Okay, so the first thing is, on the review, let's go ahead and let's take a look at what happens when you multiply a square root of any number, and I'm going to choose 2, and then you multiply that square root by itself. All right? We're going to look at 3 of these examples here, so let's just randomly pick a number other than 2. Blake Ramos, what do you say? 12. Good. So let's take a look at what happens when you multiply square root of 12 by itself. So square root of 12 times square root of 12. Or let's take a look at another number right here. For instance, I don't know, what number, Donovan, what number are you thinking of? 14. All right, that'll work. So the square root of 14, multiplying it by itself. Okay, so what's the square root of 2 times the square root of 2 equal to? Well, that's equal to the square root of 4. Why? Because 2 times 2 is equal to 4. And what is the square root of 4? Well, that is equal to 2. Okay, so the square root of 2 times the square root of 2 becomes the square root of 4, excuse me, which becomes equal to 2. Okay, if we followed along with this same sort of idea, so what would the square root of 12 times the square root of 12 be? Well, 12 times 12 is 144. Very good. And what's the square root of 144? Well, that's just equal to 12. Okay, following along with the same idea, square root of 14 times square root of 14. 14 times 14 is 196. What's the square root of 196? If you don't know what the square root of 196 is, you're going to want to probably use a calculator, but take my word for it, it is equal to 14. Okay, so what do you notice? Well, here's what I noticed right here. Whenever you multiply a square root times itself, the answer is the number which was inside the square root, okay, which, if you recall, was called the radicand. Okay, so the square root of anything, and we could put this in general terms of like a x, so the square root of x, and x could be any number, 2, 12, 14, 47, 4,556,221. Okay, but if you multiply it by itself, the square root of x times the square root of x will always be equal to, and we could just say that is equal to x. We don't even care what this is right here, okay? It would be square root of x squared, but we don't care. So that is equal to x right there. Okay, so you guys, that's the first rule that we come up with when we talk about square roots there. So there's the review that we have. Now let's get into imaginary numbers. Okay, so let's go ahead and let's just dive right into this here, and let's get into what we call our imaginary numbers. Okay, so mathematicians quickly realized that you cannot find the square root of -9. Okay, they quickly realized that it is impossible to say find the square root of -64. It is impossible to find the square root of any number if it is a negative number. Mathematicians, way back in the good old days, when I say the good old days, I mean like back in like the Greek terms, all right? Not back in the good old days when Darren was doing homework, but in the actual days when we had this here, then, or when Ethan was trying, or when Hannah wasn't reading a book when I was talking, they said, I'm talking the Greek days, you could not find an answer to this, okay? So what would happen if you tried to find an answer to this? You got out your calculator. Hold on, I gotta walk away for a second. All right, sorry about that. My nachos were burning. I had to walk away and get my nachos off the stove. All right, we're back. So anyhow, if you tried to get out a calculator and you tried to find the square root of -9, and you can see this being done right here, your calculator says that it's a domain error. That means that there's no answer to that problem. Okay, if you tried to find, if you changed -9, you said, well, what about -64? Well, your calculator says it's a domain error. Okay, so you can't do that. What happens if your calculator, what happens if you change it to -81? Your calculator says domain error. So there's no answer. You can't find the square root of a negative number. So here's what mathematicians did. They said, well, this happens a lot, believe it or not, in math, where you have to find the square root of a negative number. So mathematicians came up with a thing called the imaginary number. And what they did was they defined the imaginary number as the letter I, and it's like a lowercase cursive I, and they defined the imaginary number as I is equal to the square root of -1. So they said, all right, so here's what we're going to do. Anytime we see the square root of -1, we're just going to make it equal to the imaginary number. We're going to represent the imaginary number, and we're going to call it I, okay? Some really smart guy like Socrates did this, or Poseidon, or Zeus, or Iron Man, or somebody like that. They invented this here, okay? Iron Man invented that? No, Iron Man's not even real. Wait, no, he's real. He lives in Malibu, and he's like an actor. But anyhow, okay, sorry, I'm getting confused. So here's what they did. They said, okay, I can't find the square root of -9, but mathematicians said, but we can write it like this. We can write the square root of 9 as the square root of +9 times the square root of -1. Okay, and you know, the mathematician said, oh, that's kind of cool. Why does that work? Well, because 9 times -1 is -9, right? Just like we did here. 2 times 2 is 4. So we could do that. We could multiply that. And they said, well, what is that? Well, what's the square root of 9? That's 3. Positive or -3. And then they said, but what's the square root of -1? They go, duh, square root of -1, we just told you. It's equal to I. So the square root is 3 positive or negative I. So the square root of -9, you break down into the square root of 9 times the square root of -1. Square root of 9 is positive or -3. The square root of -1 is equal to I. So the square root of -9 is equal to positive -3I. Okay? And that's your answer. Okay? Doesn't make any sense. Well, of course it doesn't make a whole lot of sense. It makes some sense, but that's your answer. Okay? Live with it. Deal with it. 3 times the imaginary number. Okay, so how do we figure out what the square root of -64 is? All right, so the Greeks said just do the same thing. My goodness. So you take the square root of -64, you break it down into the square root of +64 times the square root of -1. Why do we do that? Well, because we can find the square root of both of those. What's the square root of 64? Think about it. Think about it, okay? Kylie, what's positive or negative 8? Good. Kylie got it in 7th period. And what's the square root of negative 1? Mr. Trutna, I don't know that. Duh, it's right there. Square root of negative 1 is equal to I. So the square root of negative 64 is equal to positive or negative I. Okay, plus or minus 8I. Okay, how about the square root of negative 81? Do it the same way. You break down the negative 81 into the square root of positive 81, which we know the answer to, times the square root of negative 1, which we know the answer to. Okay, so what is that equal to? Well, we know the answer to the square root of 81. That's positive or negative 9. What's the answer to the square root of negative 1? Well, that's equal to I, the imaginary number. Therefore, what's the square root of negative 81? Well, it is equal to positive or negative 9I. Okay? You get it? Got it? Good. Okay? So everybody said that. So the Greeks were all, oh, that's kind of cool. Thank you, Mr. Trutna, for doing that. They didn't say, thank you, Mr. Trutna. I'm not a Greek. I'm Slavic and German. And I wasn't even alive when they did this. Okay, Aaliyah? Jeez. Not even alive then. I'm only 37 years old. So anyhow, that would make me, that means I wasn't even born until like 1947 or something like that. Okay, so then they said, all right, so what do we do then? So that works out great when these numbers are perfect square roots, but what happens if you have a number that's, say, not a perfect square root? Like the square root of negative 12, okay? Well, not a problem. Here's what you do. You break it down just like you did before. You're going to change this to the square root of positive 12 times the square root of negative 1. Okay, well, the square root of 12 is not going to come out to be a nice, friendly, perfect number like this. So what you're going to have to do is you are going to have to make a factor tree of 12. All right, so if the number that you're trying to find the square root of does not come out to be a perfect, like, nice, friendly, perfect square root number, just factor it down. 4 times 3 is 12. 4 becomes 2 times 2. So that means you think of this problem as the square root of 2 times 2 times 3 times the square root of negative 1. And then what do? Well, you simplify the problem, okay? Notice that I have a pair of 2, so what happens to them? Bingo, they go to the outside. Okay, so what would this answer be? I would have a 2 on the outside. I would have a square root of 3 on the inside. So the square root of 12 becomes 2 square root of 3 times, what's the square root of negative 1? Well, that is I. Okay, so this problem would become 2 square root of 3 times I. All right, and then we write that as, we could take this I and we can multiply it by that, and we would write this as 2I square root 3. Why did I write the I next to the 2? Why didn't I write the I next to the 3? Well, because the 3 is inside the square root. Is that I inside a square root? No. So you put it next to the number that's not inside the square root. So what does that mean? It means that the square root of negative 12 is equal to 2I square root of 3. Okay, you guys? And there we go. So there's the definition of how you find square roots of negative numbers. You're going to use the letter I, which stands for the imaginary number. Okay? So far, so good. Moving on. Now let's talk about the I wheel. All right? Hang on to your seats here because we're about to get a little bit crazy on this I wheel right here. Herrera, stay with me. This is okay, you guys. We can do this. Okay? Jack, neighbors. Just pay attention right here. We got the I wheel going on, okay? Cadillac Carlos, I wheel. All right, so here's what we got. Follow along with me. So I, by definition, what is I equal to? Come on, quick, somebody. Quick. Good, it's the square root of negative 1. So I, by definition, is equal to the square root of negative 1. Okay, so that means I squared is equal to I times I. Yes or no? Say yes, of course. I times I, that's I to the first times I to the first would be I to the second. Well, what's I? I, by definition, is the square root of negative 1. So that would be the square root of negative 1 times the square root of negative 1. And we just learned what happens when you multiply a square root by itself. Well, that is just equal to the number inside. So what's the square root of negative 1 times the square root of negative 1? Well, that is equal to negative 1. Okay, so I is equal to the square root of negative 1. I squared is equal to negative 1. Okay, I'm going to write this over here. I squared is equal to negative 1. So what does that mean? Anytime you guys see an I squared in a problem, you should always replace it with negative 1. Why? Because we just showed that I squared is actually equal to negative 1. Okay, well, let's see what I to the third is equal to. Well, I to the third would just be I to the second times I. Yes or no? Of course, that's yes. I to the second times I to the 1 would be I to the third. Remember, you add the exponents up. Well, what's I to the second? We just said I to the second is negative 1. Anytime you see an I to the second, that means negative 1. So this would mean that we're going to take negative 1, and then we're going to multiply it by I. What's I by definition? It's the square root of negative 1. Okay, well, what is that equal to? You can't multiply these negative 1's together because one's on the outside, one's on the inside of a square root. So that is equal to negative 1 square root negative 1. Okay, so we just figured out that I to the third is equal to the square root negative 1, or negative 1, sorry, square root negative 1. Okay, well, let's keep going. How about I to the fourth? What's I to the fourth? Well, if I broke down I to the fourth, how could I break it down? Well, duh, that's I to the second times I to the second. I to the second times I to the second is I to the fourth. 2 plus 2 is equal to 4. What's I to the second by definition? We just said I to the second by definition is equal to negative 1. So this would mean negative 1 times negative 1. Well, what's negative 1 times negative 1? Positive 1. Okay, so I to the fourth is equal to positive 1. Okay, so what does that mean? Well, that means anytime you see an I to the fourth, you always make it equal to positive 1. Okay, you guys? And so let's keep going. Let's just for the fun of it, let's do I to the fifth. So how could I break down I to the fifth power? Well, I to the fifth power, isn't it just I to the fourth, which we know is equal to 1, times I to the fourth is just 1, times I, what's I? It's equal to the square root of negative 1. Okay, what's 1 times the square root of negative 1? Well, that's just the square root of negative 1. Well, what's the square root of negative 1? That's just I. So I to the fifth power is the same thing as I. Okay? I to the fifth power, same thing as I. So I is the same thing as I to the fifth power. By golly, let's see what I to the sixth power is equal to. All right, so how could I break that down? I to the sixth power. Let me see. Ooh, that's just I to the fourth power times I to the second power. Why? 2 plus 4 is equal to 6. Add the exponents up. What's I to the fourth power? Well, that's equal to 1. Times, what's I to the second power? That's equal to negative 1. What's 1 times negative 1? That's negative 1, which is the same thing as I to the second power. Holy cow. So I to the sixth power is the same thing as I to the second power. So I to the second power is the same thing as negative 1, which is the same thing as I to the sixth power. Look, 1, 2, 3, 4, I to the fifth, I to the sixth. Take a wild guess. What's I to the seventh the same thing as? You got it. It's the same thing as I to the third. What's I to the eighth the same thing as? You got it. I to the fourth. Okay, what's I to the ninth power equal to? See the wheel? This is called the I wheel. It rotates around like this. Notice it rotates every 4 things. So I to the ninth power would be the next thing here. So that's the same thing as I to the fifth power. So I to the ninth is the same thing as I to the fifth, which is the same thing as I. What do you think I to the 10th is going to be the same as? Gosh, you guys are absolutely amazing. I to the 10th would be the same thing as I squared. So what is the I wheel? The I wheel is just a wheel that we use to remember that the imaginary number, it repeats itself every 4 times. So we've got I to the third, we've got I to the fourth, and we don't have to do I to the fifth, sixth, seventh, eighth, and so on and so forth. Why? Because they're the same as this wheel right here. Okay, now a couple things to remember. What's I squared always going to be equal to? Negative 1. What's I to the fourth always going to be equal to? Positive 1. Okay, so we have that there. All right, so here we go. So if I said, all right, guys, here's what I want you to do. I want you to simplify, okay, simplify using only one I. And I say, what is I to the 13th power equal to? So what I'm asking you is, if I did the I wheel, where would I to the 13th be absolutely equivalent to out of the I wheel? Well, let's count. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I to the 13th power, if I simplified it, it becomes I. Okay, so this is how we simplify I to powers. Okay, so how about I to the heck, I don't know, which one do you want to do? Let's do I to the 22nd power. Let's see what that is. So how do we do that? We count the I wheel. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So I to the 22nd is the same exact thing as I to the second. What's I to the second equal to? -1. So if I said simplify, holy cow, the lights just went out here. I got to pay the power bill every once in a while. Hey, I paid the power bill. The lights are back on. Okay, hold on, I'm eating some of my nachos right now. Whoo, those jalapenos they're spicy. Spicy, just like Kin Lee and her attitude, and Nick Yang, and the Yang twins, Nick and Kenji. Okay, all right, so I to the 22nd, if we simplify it, it's I to the second, which is simplified to -1. Let's do uno más. That's Spanish for one más, if you didn't know that. Okay, let's do I to the, how about the, I don't know, let's not do it too big, so let's just keep it real, man. How about I to the 11th power? How do we simplify that? We go to the I wheel and we count. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I to the 11th is I to the third power. Do you make I to the third power equal to something special, like I to the second is equal to -1? No. Okay, the only thing that you make special is I to the second, -1. I to the fourth is equal to +1. Okay, do you guys understand the I wheel? Yes? No? Kaylee Lord, you got it? I wheel? How many parts are in the I wheel, Kaylee? I'll tell you what, take your last name, add 1 to that. 4, good job. Okay, yeah, 4 in the I wheel. Ignacio, how many parts are in the I wheel? Take your last name, number of letters. 4, good job, Ignacio. Man, you guys are on top of things. I should not be here more often. I'm proud of you guys over here. Okay? Yeah, the I wheel has 4 things. So there's the I wheel right there. Okay? All right, let's get to the last thing. Adding and multiplying imaginary numbers and real numbers. Okay? So here we go. Let's do adding. How do you add imaginary numbers? Well, adding imaginary numbers is, so if I say, hey guys, what's 3i plus 7i? What you do when you add these is you add them just like they're x's. So if I said, what's 3i plus 7i? If I said, what's 3x plus 7x? Hopefully you would say the answer is 10x. So what's 3i plus 7i? Well, the answer is 10i. Okay, so 3i plus 7i is 10i. And it works the same with negatives. So if I said, what is -2i plus -14i? That would be equal to -16i. All right, you guys? So what do when you're adding imaginary numbers? Add the number in front or subtract the number in front, whatever you're doing, adding or subtracting, then leave the I as is, okay? Now, of course, you have to be careful. So if you have parentheses involved, like say I had parentheses 4 minus 2i, all right, and then I said minus another parentheses 8 minus 7i. So what happens if you have imaginary numbers and real numbers in the same problem? Like 4 and 8 are real, and -2i and -7i are imaginary numbers. So here's what you do. First of all, you want to rewrite the problem without parentheses. Okay? So There's a 1 there. There's a negative 1 there. Remember to rewrite the problem without parentheses. You distribute by the number in front of the parentheses. So what is 1 times 4? That is 4. Okay, minus, and that's what's 1 times 2i? Well, that's 2i. So you could multiply a real number like 1 times an imaginary number by 2i. You just treat it like it's an x, okay? How about this one over here? What is negative 1 times positive 8? That would be negative 8. And then what is negative 1 times negative 7i? Well, that would be positive 7i. Okay, so you guys, if you ever have parentheses involved and you're asked to subtract or add, doesn't matter, get rid of the parentheses first. Now, what do? We combine like terms. Okay, what's like with the 4? Is the minus 2i like with the 4? No, that's a real number. That's an imaginary number. Okay, what's like with is negative 8? Yeah, that's real. So we can put those two together. What is positive 4 minus 8? Negative 4. Very good. Okay, and then we can combine the imaginary numbers together. All right, so once again, when you're adding or subtracting, you add or subtract the number. So what's negative 2 plus 7? That's positive 5. And then you leave the I alone. So you guys, I would get negative 4 plus 5i. Can you add those up together? No, you cannot add a real number to an imaginary number. So this would be your answer here to that example. So we have example number 1, we have example number 2, we have example number 3 of adding, okay, imaginary numbers. Now let's go into multiplying imaginary numbers. All right, so when you multiply imaginary numbers, here is example number 1. Let's say I say take the imaginary number 2i and multiply it by the imaginary number 3i. So we have real numbers 2 and 3. We have imaginary numbers I and I. Okay, so how do you multiply these? Well, you multiply the real numbers together, 2 times 3, that's 6, and then you take the i's and you follow the rule of exponents. This I has an exponent of 1, that I has an exponent of 1, so what do I do with the 1 and the 1? I add them, so I to the 1 times I to the 1 becomes I to the 2. So 6, I would get an answer of 6i to the second, okay? But going back to our rule that we said right here, boom, there it is, right there, there's the rule. Every time you see an I squared, what do you always replace an I squared with? Say it together, negative 1, okay? Repeat with me, chant with me. I squared equals negative 1. I squared equals negative 1. I squared equals negative 1. You need to remember that, okay? Anytime you see an I squared, you always change it to negative 1. Why? Because I squared equals negative 1. All right, so I have an I squared. What do I replace it with? Oh, nobody. Negative 1. Thank you, Matea. So this becomes 6 times negative 1, so that is equal to negative 6. So 2i times 3i is equal to 6i squared, which means 6 times negative 1, because I squared is negative 1, which is equal to negative 6. So ultimately, 2i times 3i is equal to negative 6. Number 2, how about if I said, what is 12i? And then I said, multiply it by 4i. Okay, well, we're going to do it the same way. We're going to multiply the real numbers times each other. 12 times 4, that's 48. Then we're going to multiply the I times each other. What is I to the first times I to the first? That's I to the second. Okay, but what does I to the second mean? Negative 1. So this means 48 times negative 1, which is equal to negative 48. So 12i times 4i is equal to negative 48. Okay, so let's do another one. How about if I said this right here? How about if I said take 2i, multiply it by 3i. Okay, that's no big deal. We did that in number 1. But then I said multiply it by 4i, and then multiply that by 5i. So 2i times 3i times 4i times 5i, okay? Well, how do we do this, you guys? Well, we multiply the real numbers together. 2 times 3, that's 6. 6 times 4, that's 24. 24 times 5, that is like a really big number, 120. Okay, so I'm going to get 120. 2 times 3 times 4 times 5 is 120. Then I have I to the 1 times I to the 1 times I to the 1 times I to the 1. That is I to the 4th power. So this multiplies out to 120 I to the 4th power. Well, let's look at a rule. Whenever I see an I to the 4th, is that one of my special replacements? Yes, I always replace I to the 4th with positive 1. Okay, we worked it out right here. So this really means 120 times positive 1, so that's equal to 120. Okay, you guys, so that would be how we multiply those numbers together there. Okay, all right, 2 more examples and then we are done. I've only been talking for 30 minutes. Don't say it. That was 27 minutes longer than I was hoping for, Mr. Trutna. Hey, we're on a block schedule. We got 2 hours, so just, deal with it. And so work it out from there. Okay, number 4. How about if I said, what is 2 minus 9i? And then I wanted you to multiply that by 3 plus 4i. Okay, so we have a binomial involving a real number and imaginary number times another binomial times multiplying by a real and an imaginary number. So how do we multiply these? Okay, well, if you recall, when you're multiplying binomials, you could use the rectangle to help you out. Okay, so I'm going to draw a rectangle. The first parentheses I'm going to write along the top of the rectangle, so a 2 minus 9i. Then along the side, I'm going to write what's in the second parentheses, 3 plus 4i. Hopefully you remember doing this. Now at the minus sign, I'm going to draw a line. At the plus sign, I'm going to draw a line. So then I'm going to multiply the parts of each. I'm going to multiply to get answers in each rectangle. Then I'm going to combine them to get my final answer. This is how we would multiply these out. Okay, so let's multiply the top left rectangle. How long is this side? 3. How long is that side? 2. So we would go 3 times 2. 6. So that rectangle is 6. Okay, let's go down to the bottom left rectangle. How long is this side? Positive 4i. Times, how long is that side? 2. What's 4i times 2? Well, that's 8i. Okay, so the bottom left rectangle becomes 8i. Okay, now we go to the top right rectangle. How long is this side? We already said it. It's 3. Times, how long is this side of the top right rectangle? You got to be careful. I see a 9i, but we have a minus sign there, so it has to be a negative 9i. So what is 3 times negative 9i? That is negative 27i. Okay? And then to get my bottom right rectangle, how long is this side? We already said it. It's 4i. Positive 4i. I don't have to write positive. I could just write 4i. Times, how long is this side? We already said it. It's negative 9i. Okay, so what is 4i times negative 9i? 4 times negative 9, that's negative 36i squared. Okay, so there's my answer. It is 6 plus 8i minus 27i minus 36i squared. Okay, so that is my answer, and that would be my final answer if I can't simplify and or combine like terms. So my first question is, can I simplify? Okay, not combine like terms. Let's just see if I can simplify. Can I simplify 6? No. Can I simplify 8i? No. Can I simplify minus 27i? No. Can I simplify negative 36i squared? Yes. How? Well, every time you see an I squared, what do you replace it with? A negative 1. So this last part really is negative 36 times negative 1. Okay, why is that? Because remember, I squared is negative 1. Okay, so really this problem means 6 plus 8i minus 27i, and then what's negative 36 times negative 1? That is a positive 36. So when I simplify, this is what my problem becomes. Notice the I squared is gone now. It became negative 1, which made that a positive 36. Now, can I combine like terms? Absolutely. Okay, what's like with the 6? Not the 8i, not the minus 27i, but the plus 36. What's positive 6 plus 36? That is 42. So I get a 42. Okay, then let's go to my next term. Is there anything like with the positive 8i? Yes. The minus 27i. Can I put those two together? Yes. Remember, when you're adding or subtracting i's, add or subtract the leading number, that's the coefficient. What's positive 8 minus 27? That's negative 19. And then leave the I alone. Okay, is that your answer? Can you subtract 19i from 42? No. So that is your final answer. So we just found out that if I take 3 plus 4i and I multiply it by the binomial 2 minus 9i, I get an answer of 42 minus 19i. Notice when I write my answer, I always write the real number first and then the imaginary number part second. Okay? So we're not going to do step number 5, but here's what's going to happen. Your teacher, not me today, but your teacher is going to ask you to do 2 things for the remainder of class. And these are the 2 things that we want you to do. Number 1, you want to do Unit 11, Worksheet 3A. That's being passed out to you, hopefully very soon, if not right now. Okay, and what you're going to do is, there's a lot of problems that I want you to do, but I want you to, holy cow, I got to pay the electricity again. There we go. Okay, the electricity is back on. I'll have a little bit of nachos again, but anyhow, I want you guys to do numbers 1 through 6. There's more than that, but just do these numbers. So maybe you want to write these down right now. Okay, 1 through 6. Then I want you to do numbers 10 through 12. All right? And then 16 through 21. Okay, guys? And then lastly, number 28. Okay, so 1 to 6, 10 to 12, 16 to 21, 28. Okay, when you get done with that, and you should get done with that before the class ends, then I want you to go to mathexcelforschool.com. So in other words, there are laptops up in the front of the class. Okay, go to that website right there, Excel for School, excelforschool.com, and I want you to do Unit 11-2. Okay, and that would be your homework due on Friday. All right, guys, enjoy, work hard on this, and then when I see you on Friday, hopefully I'll see you on Friday, feel free to, we'll go over some more clarifying questions.